So I want to welcome everyone back. I'm Imad Shihab. I'm a professor from Concordia University, Canada, and I'll be chairing the next two talks in this session. So first, I would like to welcome Dr. Ipek Ozkaya, who's a principal researcher and the technical director of the Engineering Intelligent Software Systems Group at the SEI in Carnegie Mellon University. She is the outgoing editor-in-chief of IEEE Software and has authored many books, or at least one book on the relationship of technical debt and intelligent systems, particularly its relations to industry and practice. Ipek, the floor is yours.
Very much. Thanks a lot for having me today. And I'm going to be talking to you about software development lifecycle in the area of foundation models, right? That's what we're here for. We're excited, a little scared, a little nervous, but mostly excited, right? That's where we are. So before I get started, I would like to give you some context. Yes, I come from Carnegie Mellon University. Those of you who are paying attention, Carnegie Mellon University takes pride in leading the way in computer science, AI, and is ranked among the top universities, not only in the United States, but globally. I do belong to Carnegie Mellon University, but I represent another portion of the community from that perspective. I am at the Software Engineering Institute, and it's important for me to explain this to you because I am not a professor, although I'm a CMU employee and have a PhD from CMU, in fact, an alum as well. The Software Engineering Institute, those of you who might have been paying attention in the past couple of decades might know SCI as the Process Improvement Organization or Cybersecurity Organization, or more recently as the AI Software Architecture and Forward-Looking Software Engineering Practices. The special aspect of the SCI is we are a government-funded, Department of Defense-funded, federally funded research and development center. What that means is we work with software that is typically not only a couple decades old, but it's envisioned to survive and be maintained a couple decades into the future. So that's the context we're in, and that's important to recognize because when we're looking into some of these emerging technologies, we have to look from the perspective of how do I insert it into existing software and how do I envision evolution within that ecosystem. And currently at the SCI, we have three divisions, one focused on software systems, one focused on cyber, and one focused on AI, and I come from the software portion of the organization. I myself lead a team of about 30 engineers, researchers, and data scientists, and we're called Engineering Software, Intelligent Software Systems, and this is also important to recognize from the perspective and the work that I'm representing here. You might be familiar with some of the work that came out of our team in software architecture and managing technical debt. Quite a number of organizations as well as universities use some of this output in their curricula. And the way we engage with emerging technologies is this backdrop in terms of how do I insert the technology into existing software, how do I make the trade-offs in terms of where to focus and where not to focus. Some of the recent work is focusing on looking into principles of AI engineering, incorporating some of these AI models into edge software systems because a lot of the time the software systems ecosystem that we deal with are heterogeneous. It's a system of systems. There are many interactions between different parties and they need to exchange information. And most recently, of course, generative AI and large language models. A couple years ago, again, those of you who are paying attention may be familiar with this, we started a body of work around 2019 looking into what does it mean to make software as a national priority within the United States, but also looking into globally. Little did we know some of the things that we envisioned at the time would overnight become reality. We were envisioning about 5 to 10 years projection into that. And in fact, AI-augmented software engineering was one of those areas. I'm going to very quickly show the 6 areas. I don't have time, and this is not the focus, but there were 6 areas that we envisioned that was in relationship with each other. Why is this important to understand? Because some of those, like for example, the one in terms of engineering quantum and software is in fact related to what we're thinking about in terms of AI. The infrastructure, the hardware, the socio-technical environment, compositional software, and the assurance of that software is as important as we're developing in this. I'm going to focus on the AI-augmented software engineering piece, but it's important to recognize that these are happening all in relationship to each other. So what do I mean when I talk about AI-augmented software development? It's the balance between do better versus do differently. That's how we envision it. And when we talk about AI, we don't necessarily mean just LLMs, but AI-based and other tools that are used together to improve the efficiency of the software engineers and reduce their cognitive overload. And this is really shifting their attention to tasks that they need to focus on and automating as much as possible to the tasks that could be automated. Earlier, Ahmed mentioned this. There is a partnership that is being envisioned. This is not going to go away. It's in fact going to be much more central. And there are many different roles that we're going to observe. We're already observing, but those roles we're going to get defined much, much more specifically. And you can actually read some of these in the national agenda, the intern, the partnership, and so on and so forth. What I would like to focus on your attention in terms of how we're envisioning the software development processes to evolve is that sweet spot between do different and do better. There's a lot of research, and there's a lot of exciting research that is coming out of collectively both from industry and academia. I think most of it is currently focused more on the do better side, meaning, for example, if I'm testing, how can I test quicker? How can I find more bugs? How can I maybe shift the attention of the testing by using some of these tools? That's where the do better comes in. This is all great because it creates improvements and efficiency, but what is the do differently? And I think some of the points that Ahmed made really look into that do differently perspective. And I'm going to ask you to think with me in terms of the do better, do differently as well. As we think about AI, there's a potential confusion that we all fall into. And what we try to do is we try to look into it, all right, what is it that we're developing and what is it that we're focusing on? We like quadrants, so this is like a quadrant. So on one axis, we have the degree of AI augmentation in the software development lifecycle, and in the other axis, in the y-axis, we have the degree of AI augmentation of system operations. This is important to recognize because AI is not only being used to develop systems, but there are models, AI models within the systems that are helping us with improved decision making. And those things get not necessarily confused, but become overlapped, and understanding what is happening where and what is being created where becomes important. Of course, where we are, let's say today, or within the past couple of years, is conventional systems developed with low degree of AI augmentation, the tools that we're used to, and low degree of AI within them. Any conventional system that you might think of, we gave some of the examples, and there's details in the links that I have there. And the next part is using the low level of AI augmentation in the software development lifecycle to develop a system that might have an ML element, ML component, or AI component within it. An ML-based e-commerce system is maybe an example. So we are moving from that part of our quadrant to a part where we're really pushing our thinking in terms of how we're incorporating these tools. Mostly, how do I move as high as possible in the AI augmentation in terms of developing conventional systems. And I think that's where some of the traditional software engineering lifecycle and whatnot might come into play. And of course, the holy grail is we are seeing, okay, I'm developing AI systems with AI tools. There's levels of complexity, there's levels of probabilistic reasoning, and there's levels of data that is going into it. There are differences and there's maybe overlaps as well. This is important to recognize because sometimes we confuse ourselves, but also we confuse our audience. So mostly I'm talking about, when I'm talking about the AI-augmented development lifecycle, is moving the needle in terms of the tools we use in developing either conventional or AI systems that have AI components. I would like to maybe spend 10 seconds here as we look into this great quote by Grady Bush. A fool with a tool is still a fool. It's very important to recognize that these, at the end of the day, these are tools. Humans are developing these tools. Yes, there's relationships and results within them that we may not be able to understand, and it's surprising us in some ways, but at the end of the day, it's going to be the humans who use it, so we need to really recognize that it's as important as input. So when we look into the opportunities of generative AI and how we develop the development, how it improves software development, it's fair to say that things are changing. It's not important to say they're going to change, they're already changing. So there are two aspects of it. How do we assess the opportunities, and how do we challenge the workflows? Here, when I talk about workflows, the work we do looks into both the high-level end-to-end software development lifecycle, starting from the business goals, requirements, to the end when the software finds its user, as well as smaller workflows. For example, what does it mean to test the software? What does it mean to implement a requirement? So there is a hierarchy of workflows that you need to balance into that. As one of the activities within our team, we looked into what might be some of the use cases that different stakeholders might envision. It's important to recognize the different stakeholders because as I showed you the different quadrants and different kinds of software, there are different individuals that engage with the creation of software as well as the use of the software as well. So we have a bunch of use cases that we've developed, and I'm not going to go through these because what's important in these use cases is not necessarily the details. You can read all of that in your own time, but the individuals that are involved in those use cases. What I mean by acquisition in this context is within the highly complex software development ecosystems like government software, there are contractors, there are acquirers, there are different organizations involved within the creation of software systems. And that becomes important to recognize because sometimes it's the acquirers who might have the requirements and there are multiple handovers. So those handovers are important to also recognize when we're thinking about a new software development lifecycle, especially with generative AI tools. So what you need to pay attention in these bunch of use cases, that we have quite a number more, is the different stakeholders. We're talking about not only technical stakeholders here, but we're talking about stakeholders who may not have thought of software engineering or engage in the software engineering from that perspective. So it's important that it's a human-AI partnership, not only with people who might understand software, but people who understand the domain well and engage with software development. So that's an important aspect of the software development lifecycle as we envision the future. I would like to take you a little bit into the memory lane, to the past, because at the end of the day, the activities in the creation of an artifact, a system, probably are not going to change. It's really how we combine those activities and how we group them change. Like when in the good old days, the waterfall software development process, we have the requirements, the analysis and design, implementation, testing, and deployment and maintenance. We introduced delays as we discover each issue late, and then we came up with the iterative and incremental software development lifecycle. We recognized that mistakes were too late to find. We said, you know what, we need to do more test-driven development. Let's move the testing earlier on. So we talked about the test-driven development as an aspect of it. Well, we get stuck when we deploy the software to operations, hence we started talking about the DevOps processes. So the evolution of software development processes is in reaction to a problem, a roadblock that we were facing. What we're living through altogether is not where we had a problem, hence we need to solve the problem. There's a tool, almost like a hammer. Where do we hit that hammer? So it's our responsibility to step back and say, okay, what is the problem that we are going to try to solve? So if we look into these, again, processes and their evolution, from the waterfall software development process perspective, well-defined, the success was it created these well-defined tasks. We could start talking about workflows through different bodies of activities. We could start talking about expertise in requirements, implementation, design, test, whatnot. The challenge, the feedback loops were challenging because of the handovers, And that was where the automation efforts focused on, like modeling the tools to support the design and conformance, requirement traceability tools. We called them beasts at the time because we knew that you needed to input all that information, and that was not trivial. For example, LLMs is already making that process a lot easier. But again, the automation was to answer a problem in that process. If we look into the iterative and incremental development lifecycle, the success improved communication between different parties. The challenge, through that improved communication came chaos, everybody collective ownership, and lack of discipline. We lived through that with the agile software development era. But there were also very successful automation efforts. Workflow management tools, in fact, came as a result of those challenges, improved code analyzers, and progress in terms of the understanding the developer's workflow process. And lastly, the DevOps, success in terms of the improved delivery tempo with reduced errors. I put a question mark there because we all know that a lot of developers turn off all the tools that are in the CI/CD pipelines. So the tools are there, whether you're using them or not is a whole different story there. And the challenge was to reduce the handovers with automation. And again, there's quite a number of tools that came with automated code review, testing, and so on and so forth. So what's happening in terms of the AI-augmented lifecycle improvements now is mostly focused on the do better. And I know some of the authors are here in some of the references that I have here as the behind. This is great work. I do not mean this that it's not, should not be focused, but we need to understand whether we're improving existing software development processes or we're envisioning a different process for optimizing on a different goal. And I'm not going to go in detail in these, but the takeaway from these is some good examples of work that is happening in application of foundation models to different areas, but each piece of these is a workflow of itself. For example, test automation, right? How are you looking into design test cases and localizing and triaging those crashes? That's a workflow on its own. Large language models, foundation models are improving that workflow in quite an effective way. That is not necessarily changing the software development lifecycle. It's really shrinking maybe some of those activities and creating improvements there. Requirements generation, again, another great example where converting requirements to machine-readable format, there's a lot of good use cases in terms of application of foundation models, large language models there. Auto code completion, that is where Copilot, in fact, excels. In an early work, in fact, actually has data that says developers are a lot more efficient, they feel like much more engaged within the process, and so on and so forth. But again, their process doesn't change, it's that the tool makes them more efficient. Some more examples, code commit generation, the mining software, I'm in front of a mining software repositories research group, so that work continues, and that work is going to continue to thrive, but again, it's making improvements into existing processes. Program repair, similarly, as well as code review. The point here is that there are many, many more, and I just picked some examples to demonstrate the point. The takeaway here is that what is the task workflow that we're looking into, and how do we orchestrate multiple workflows together? And foundation models are definitely going to help us in that department. However, what we're facing now is how should an AI-augmented software development lifecycle in fact be structured, and what is it that we're looking at? Ahmed really put it into the perspective of maybe there is no code. Whether there's code or data is not necessarily important here. It's what problem we're solving is maybe the challenge that I'm putting for all of us to think through. Our challenge is not necessarily to use the tools. Our challenge is what we're trying to improve, and what new roles and stakeholders are we empowering with these new tools is really where we need to focus on. So if we look into the key insights that happened as these different software development processes evolved between waterfall and iterative software development lifecycle, the key insight was doing all tasks in smaller scope of requirements enabled the feedback loops to be quicker, and as a result, tracking the scope better rather than facing the problems at the end. Between iterative, incremental, and test-driven development, the key insight was writing the test first through requirements and implementing against them, as opposed to implementing at the end. And most of the time what happens there is that you run out of time and you're not able to, in fact, execute them. And the key insight between when we introduce the DevSecOps processes is integrating continuously so that we find those not only early on, but it's easier to integrate smaller pieces as opposed to when you're at the end, you realize that you're actually holding different legs of an elephant, but nobody knows that it's an elephant. So those are really the insights that helped us move forward. So the questions we should be asking is, what are the right units of abstraction in the area of foundation models? They are multimodal. We do say large language models, but we are now looking into all kinds of other modalities that are integrated. For example, does the scope of work or batch size change? Batch size is important in software development processes or any work, not just software development. Where are we talking about lines of code, classes, multiple classes, requirement stories, pull requests, data or design construct? We're probably talking about all of them all together in a hybrid way, and we need to figure out how that heterogeneous scope of work and batch size really moves throughout different phases. Where does the ground truth exist? We have gone through and I come from a software architecture perspective. There's always, well, the ground truth is always in the code versus the model, and how does that traceability work, and so on and so forth. We could talk about that forever. But where does the ground truth get created? Is it the code? Is it the architecture? Is it the data? So that's also important. And I think some of the envisioning of, well, the code doesn't exist, but somewhere the ground truth needs to be created. And how do we track that? And how do we create the trust as well as verifiability and verification cycles? What do you look for? Are we looking for correctness? Are we looking for mistakes? And by that means, are we ensuring that it's going to be correct? Or are we going to develop mechanisms that we are able to check mistakes so easily, mistakes will not be a problem? When we look into larger systems, think about, for example, urban platforms. Nobody says there will never be problems in the utility pipelines. Trains will never crash. There are mechanisms to try to react to those fast. So maybe there's a different task that we'll have to think about in this area of foundation models as well. Again, data is the loudest participant in this. What is the data that we need to create? What is the data that we need to persist? What is the data that we shouldn't persist from a responsibility perspective is a key question as well. The different roles, any engineering endeavor is a collaboration endeavor between different stakeholders. And it's important, we should not assume that the stakeholder is just the developer or the software engineering team. Who are the roles and how are they interacting become important in the area of foundation models. And because this is such a complex endeavor, the infrastructure that these tools as well as software runs is critical. We will need data. We're already looking into multiple petabytes of environments that the models, what is going to go through the models. There's distributed development environments, so that infrastructure is important, and the unit of design in that infrastructure is critical. These are engaging questions, so this is not going to obviously happen overnight, and as we go through these changes, we can go back and think about it. What have we improved throughout history to improve efficiency of development and quality of our products, and how can we take advantage of these tools against the same goals is really the question we should be asking. So I'm going to leave you with a question. How should the AI-augmented software development lifecycle really be structured? We all have our ideas. The work that we do at the Software Engineering Institute looks at the dependencies between workflows, the larger workflows when we look into the structure and behavior of systems, when multiple systems need to interact, and when I'm talking about multi-million lines of code over 3 decades, 4 decades of development as well as sustainment, versus how we might be looking into incorporating them as into new development. So the challenge, this is maybe something to put forward, the speed and correctness at scale and respond to change at scale with trust, as well as the design competence, because the way these different elements and units interact will really require us thinking about how we compose them, how we take advantage of them, and how we evolve them, especially with data. And the key insight, Maybe we'll come out of it within the next couple of days, but I think we'll see a lot faster than we've seen in the evolution of this. In fact, when our national agenda was out, we did not think that within a year we would be enacting some of the recommendations. I was, as in my role as the editor-in-chief, writing one of the editorials about generative AI. I had to change the paper 3 times within a month because of the changes that happened that quickly. This was last March, in fact. So it's an exciting time to be a software engineer, and thank you very much.
Thank you very much, Ipek, for a very nice talk. So we'll hold off the questions until the panel, which will happen next, and Ipek and Dai will be both on the panel. So thank you once again, Ipek.